have you finished this numerical? The bob of the pendulum is released. That problem we were doing, right, yesterday?
Yes,
Yes,
ma'am.
sir.
Yes, sir.
Yes, sir.
You were
Solve.
dictating the question.
The bob of a pendulum is released from a horizontal position A, as shown in figure. Horizontal position A, as shown in figure. .5 meter. If the length of the pendulum is 1.5 meter, if the length of the pendulum is 1.5 meter, what is the speed with which? What's the speed with which? What is the speed with which the bob arrives at the lowest point? The bob arrives at the lowest point. The bob arrives at the lowest point, B. Lowest point B. Given that it dissipates 5% of its initial energy against friction. It dissipates 5% of its initial energy against friction. That means this is the height, okay? It is lifted. There's a height it's lifted actually. From the lowest point, this much height it is lifted. So that is mgh. Agreed? This is a potential energy. This is equal to potential energy. While it is coming down, it will change into kinetic energy, half mv squared ek by law of conservation of energy. But 5% of energy is lost in the form of heat due to friction of air. How much energy will be remaining now? On this travel, 5% lost. Then how much will be remaining?
95.
95.
95.
So we can say Ek is equal to 95% of this Ep. Isn't it? So Ek is half mv squared. So equal to 95 by 100 of Ep is mgh. Calculate. Here 5% lost, remaining 95% of mgh. It will go to here. So from here, if you calculate V, your answer will come 5.33 meter per second. But answers you must verify, okay? Yeah.
Sir, what was the mass?
Mass is not required, right? Mass will cancel.
So we can take gravity as 10 here.
Mass cancelled.
So we can take gravity
Sir.
10 here.
10 you take or 9.8, it's up to you. 9.8 I have taken here. No, here I have taken 10. Since it's not given, you can take anything.
So, sir, actually, we will get V square is equal to 15, right? So, sorry. It's 15 into 95 by 100.
Sir, I got root 28.5
Root 28.5.
per second.
Root 28.5.
Yes, sir, 5.33 only.
Next question. A bullet of mass 0.0012 kilogram. A bullet of mass 0. A bullet of mass 0.012.
Sir, bullet of mass what?
A bullet of mass 0.012 kilogram, and horizontal speed 70 meter per second. Horizontal speed
So
70 meter per second.
0.012.
A bullet of mass 0.012 kilogram and horizontal speed 70 meter per second. 70 meter per second. Strikes a block of wood. Strikes a block of wood of mass 0.4 kilogram. Of mass 0.4 kilogram. And instantly come to rest. And instantly come to rest. And instantly come to rest. And instantly comes to rest with respect to block. Instantly comes to rest with respect to block. Now this become a single body with respect to block. So this is a non-elastic collision because after collision they both stuck together. Will they remain stationary here? No,
No,
it will
sir.
travel, right? It will go.
Yes, sir.
Height it.
Yes.
Continue. The block is suspended from the ceiling. The block is suspended from the ceiling. The block is suspended from the ceiling by the wires. By the wires. The block is suspended from the ceiling by the wires. Calculate the height to which calculate the height to which calculate the height to which the block rises. Calculate the height to which the block rises. Calculate the height to which the block rises. Also estimate the amount of heat produced by the block. Also estimate the amount of heat produced by the block. Look, first let us calculate. This is before collision. This region, this is before collision we can consider, right? This is before collision. This is after collision. Okay, we will apply law of conservation of momentum right now. By law of conservation of momentum, right? By law of conservation of linear momentum, by law of conservation of linear momentum, 70 into 0.012, 0.012, 70 into mv, right? 0.012, mass into velocity, 70, plus 0.4 into 0, isn't it? Before collision, m1 u1 plus m2 u2. That means m1 is 0.012, its velocity is 70, but m2 is 0.4, its velocity is 0. That's equal to, now this is stuck together, m plus m. How much will come m plus m? 0.012 plus 0.4 into velocity 0. Sorry, it attains a common velocity, right?
Yes, sir.
Now both travel together with the velocity v. Any doubt?
No, sir.
It gets stuck together, completely non-elastic collision. So this gets stuck together, they travel with the common velocity. Now from here
Yes,
we
sir.
can calculate how much is the velocity attained. Clear?
Sir,
This is 0.012 into 70. This
Sir.
will be 0. So equal to, how much will come this one? 0.412, right? 0.412 V. Isn't it?
Sir.
0.4, 0.012, 0.412.
Sir,
Find
why
out.
didn't, sir, at last, in the after collision, they will get displaced, right? So it will get like zero, the total mass into zero velocity, right?
How displacing means with zero velocity it will go.
No, ma'am. No, sir. After displacing.
After this bullet hitting with this, the time
sir.
it hits here, what will be the velocity?
Sir, that common velocity will be there.
Common velocity. That velocity only I am calculating. Then only it will travel.
Yeah. Okay, sir.
Isn't it? After
Yes,
that,
sir.
first you hit velocity, then only it will travel, right?
Yes, sir.
After hitting, this will gain a velocity.
Yes, sir.
Then it will travel.
Sir, how the velocity is common?
If they are stick together and moving together, then what will be the velocity of the bullet?
Alright, sir, got it.
Hmm?
Yes, sir, it will be equal to that
A car is
velocity.
moving, you are jumping into the, a bus is moving, you are jumping into the bus. What will be a velocity after jumping into the bus?
The velocity of the bus.
Velocity of the bus. You will have a common velocity.
Yes.
Okay, now finish it B. Now answer B, you will get
2 meters per second.
2.01 something, right?
Yes, 2.03.
2.03 meter per second. This is velocity. Now let us come to this side calculation. So first part is over. We got common velocity. Now what we are going to do? Law of conservation of energy. Total kinetic energy of this body, half into, this will be half into m plus m into v squared, right? Half into m plus m into v squared. C equal to m plus mgh, right?
Yes.
M plus m gh. Now this is the kinetic energy of this body, half m plus m v squared. V is this velocity. Using this travel to height h. Their mass of the body m plus m gh. So here this can be cancelled out, isn't it?
Yes, sir.
Then we need height. Half into v squared we know 2.03 into 2.03 divided by g. G means 9.8. Is equal to h.
So 0.2 meters.
0.20
2 meters.
centimeters.
0.2 meters.
Yes, sir. 0.2.
0.2 meter, correct. H is equal to 0.2 meter. Any doubt?
No,
sir.
sir.
Now, how much energy is losing in the form of heat during this collision? That means before collision, only bullet has energy, right?
Yes,
Yes.
sir.
After collision, that becomes total energy for both of them. So we have to write here kinetic energy of bullets. Kinetic energy of bullet is half into 0.4 mass into velocity. Sorry, 0.012,
012, sir.
0.012 into velocity 70 into 70. This is kinetic energy before collision. Clear? And after collision, kinetic energy of the block and this bullet together. Okay, how much will come? Half into m plus m. That means 0.012 plus 0.4 into common velocity. Now it's moving with the velocity v square, right?
2.03.
2.03 into 2.03. Okay, after calculating, we can subtract this from this. Okay, otherwise KEF minus KEB directly we can take common, we can take outside and subtract. That time we may make mistake. That's why I'm telling you do this way.
So 2.63 is the common velocity, right?
2.03,
63 V.
not 63. Then after this, you have to subtract KEF minus KE. Final kinetic energy minus kinetic energy of the bullets. It will come minus 28.56 joule. This is the answer I got. You check.
Sir, why minus is coming here?
Energy lost,
Sir,
right?
sir, I'm getting minus 28.57 as the
Yeah.
answer.
Sir, minus 28.56.
Correct, right? Oh. Next
Yes,
numerator.
sir.
A man weighing 60 kilogram. A man weighing 60 kilogram. A man weighing 60 kilogram. Climbs up staircase. Climbs up staircase. Carrying a load of 20 kilogram. Carrying a load of 20 kilogram on his head.
Sir, could you repeat once?
A man weighing 60 kilogram climbs up a staircase carrying a load of 20 kilogram on his head. The staircase has 20 steps. The staircase has 20 steps. Each of height 0.2 meter. Each of height 0.2 meter. If it takes a time of 10 seconds, if it takes a time of 10 seconds to climb, find his power, find power. Power is equal to work by time. Here we know work done in going this way to the height or straight away here, both are same. So here
Yes,
work
sir.
is equal to mgh. So we can do here mgh by time. So power is equal to mass, his weight plus man weight plus this 20 kilograms. So 80
kilogram.
80 into 10 into height. Height how much? 20 into 0.2, right? Each step 0.2, 0.2, 0.2, 20. How much? 20 into 0.2 height. Divided by time, how much? 10 seconds.
10 seconds.
So it will be 320 in the end, the answer.
320 watt.
320 watts power.
Mass is 60 kilogram, right? So it's written 80 over there.
60 plus is carrying 20. So total 80 kilogram has to go up. Clear? Next question. What is the power of the engine? What is the power of the engine required to lift a mass of 90 metric tons? 90 metric tons of coal, COA.
Required to
COA. What is the power of engine required to lift 90 metric tons of coal from a mine, 200 meter deep? That means from a mine 200 deep, it has to take it up. That means that's a height. From a mine 200 meter deep. Per hour. Time 1 hour. Same way, power is equal to mgh by time. Here 90 metric ton is 90 into 10 to the power 3 kilogram. 1 metric ton means 1000 kilogram. Okay, 1 metric ton is equal to 1000 kilogram. Metric means 1000. So here power is equal to 90 into 10 to the power 3 into 10 into 200 divided by time 1 hour means 60 minutes into 60 seconds. 1 hour 3600 seconds. So you will get an answer of 50,000.
so why 2 times 60?
Huh?
Why 2 times 60?
1 hour 2 seconds. 1
Right.
hour 60 minutes. 1 minute again 60 seconds. Next. A car of mass a car of mass a car of mass 2000 kilogram 2000 kilogram is lifted to a distance of, lifted to a distance of 30 meter. Lifted to a distance of 30 meter by a crane in 1 minute. By a crane in 1 minute. By a crane in 1 minute. A second crane does the same work. A second crane does the same job in 2 minutes. Time 2 minutes. Do the crane consume same or different amount of fuel? Do the cranes consume the same or different amount of fuel? What is the power supplied? What is the power supplied?
Sir, do the crane consume?
Do the cranes consume the same or different amount of fuel? What is the power supplied by each crane? What is the power supplied by each crane? Neglect the power dissipation due to friction. Neglect power dissipation due to friction. First of all, calculate work done in lifting by both the crane. W1.
Sir, sorry, sir.
W1
Can
is
you
equal
repeat
to
what is the power
MGH1.
supplied?
M is 2000, G10, H1 is how much? H is 30 meter, right? Isn't it?
Yes, sir.
Yes.
That is the first answer. That is how much will come? 600,000, right? 600,000 joule.
Yes, sir.
This crane also does the same job. W2 is equal to 2000 mass, 10 G, height 30, therefore 600,000 joule. So both the crane does the same work. Work only we can say energy. That means they consume. From where they get this energy? From fuel, right?
Yes, sir.
Since they do same work, they consume same amount of fuel. Any doubt?
Sir, so according to the work done, it depends on how much fuel they consume.
How much?
Means the amount of work both the cranes do, that shows how much fuel they consume.
Well, because for this to do work, work means energy. Energy cannot be created. It should be supplied from something. So your
Okay, sir.
fuel is supplying the energy, right?
There's the same amount of work being done.
Then why it takes 2 minutes, sir?
That is power. That's the importance of this problem. Since they do the same work, same fuel is consumed. But power of the first crane is more than the second crane. So power is more does not mean fuel will be consumed more. Work will be faster. That's all. Clear? Energy consumption will be same. That is the mainly this problem says. We all think if power is more, if a machine does work faster, it consumes more fuel. It's not like that. That depends on another designs. Okay, write down. Now time will be over. Fine. So here, work done by both the crane is same. Therefore, fuel consumption also same. But power is different. Power is equal to mgh by time. Okay. So mgh is how much? 600,000, right? Divided by time, 1 minute. 1 minute means
60 seconds.
Okay. Here, same way, P2 is equal to 600,000 divided by 120 seconds.
P1 is 10,000, P2 is
10,000.
5,000.
This is 10,000 watt.
10,000.
This is 5,000 watt.
Not
But fuel
50,000, sir.
consumption will be
5,000.
same in both the cases.
Sir, 5,000, not 50,000.
5,000. Okay.
Sir, how much is 1 megawatt?
10 to the power 6 watt. Mega means 10 to the power 6. Next, a tube well. Tube well means bore well. We are pumping the water out of it with a motor.
Sir, the second power is also same.
Power, second power,
Yeah.
5,000 watt.
5,000 because 2 minutes
Yes.
it takes time.
Oh, okay, sir.
A tube well pumps out 2,400 kilogram of water per minute.
Sir, why can't we use liters instead of kilograms? Since it's water, why are we using kilograms instead of liters?
It's a question, right?
Still, for water, how can we use kilograms?
That's what I'm telling you. This is a question given by the board. A tube well pumps of water 2,400 kilogram of water per minute. We can calculate mass. See, actually, this area cross section of the pump, okay, area cross section into velocity.